If the same DTF film works well on one machine but behaves differently on another, the first reaction is often simple. Maybe the film is unstable. But in many cases, that conclusion is too fast. The film may be the same, the ink may be the same, the powder may be the same, the settings may even look similar on the control panel. And yet, the result changes. On one machine, the film feeds smoothly, ink sits consistently, powder behaves normally, and the final transfer looks stable. On another machine, the same film may show feeding instability, uneven ink interaction, powder variation, alignment issues, or localized defects that become clearer during production. This does not mean the film has no influence. Film matters a lot, but it means film performance is not an isolated property. In DTF printing, film behavior is created inside a system. The machine is a part of the system. A common mistake in DTF troubleshooting is assuming that if the material is the same, the operating condition must also be the same. But two machines rarely handle film in exactly the same way. They may use different roller structures. They may apply attention differently. Their drive systems may not pull the film with the same stability. Their internal heating distribution may be different. Their airflow may move differently. Their print heads may deposit droplets in different sizes, patterns, or timing. To the operator, the setup may look similar. To the film, the environment is different. That is the key idea. The film is not simply sitting there. It is being pulled, pressed, heated, cooled, contacted, printed on, powdered, and cured. Every machine creates its own operating environment around the film. One of the most important reasons the same film behaves differently is mechanical handling. DTF film must move through the machine with controlled stability. If the film transport is smooth and balanced, the film has a better chance of staying aligned and flat during printing. But different machines apply force differently. Roller pressure, roller surface condition, drive control, film path geometry, and take-up behavior can all influence how the film moves. Even small differences matter. If one side of the film receives slightly more tension than the other, the film may not travel perfectly evenly across its Ys. That can create stable alignment changes, feeding variation, or localized instability. This is why machine-dependent film behavior is often not uniform. One area of the print may look fine, while another area shows a problem. The film has not changed from left to right. The forces acting on it have changed. Tension is especially important because film is sensitive to stress. When tension is balanced, the film can remain more stable during feeding and printing. When tension is uneven, the film may respond differently across its surface. This does not always create an immediately dramatic failure. In many cases, a short test print may look acceptable, but during longer production, the repeated effect of uneven tension becomes more visible. The system keeps applying the same force pattern again and again. Instead of correcting the variation, the machine reinforces it. That is why a film may pass a short trail, but showing problem during extended operation. The issue was not absent during the test. It was just not large enough yet to become obvious. Mechanical handling is only one part of the issue. Thermal behavior also matters. DTF film is layered material. Different layers can respond differently to heat. When the machine's heat distribution changes, the film's internal stress and the surface behavior may also change. One machine may have more uniform heat. Another may have stronger heat zones, uneven airflow, or local temperature differences near certain parts of the transport path. This affects how the film expands, relaxes, or holds shape during printing and curing. Even if two machines are set to the same temperature, the actual heat experienced by the film may not be identical. A number on the panel is not always the same as the thermal conditions on the film surface. The article also points to the surface interaction. DTF film surface behavior affects ink spreading, powder interaction, and layer formation. But that surface behavior is influenced by how the machine contacts and handles the film. If the film is moving differently, heated differently, or contacted differently, the surface may not interact with the film and the powder in the same way. This is why the same film can support clean ink deposition on one machine but show different ink behavior on another. The material property is still important, but the machine decides how that property is expressed during protection. Another major variable is droplet deposition. Different printers may use different print heads, droplet size, firing behavior, path structures, or deposition patterns. This changes how ink lands on the film. If droplets are placed differently, the wet ink layers forms differently. That can influence spreading, edge definition, powder adhesion, and the final layer consistency. So when people say, the film works on this machine, but not on that one, the real question is often, how is each machine building the ink layer on that film? The film is the same, but the deposited layer may not be. One of the confusing parts of this issue is that the variation is often localized. If the film was simply defective, people might expect the whole print to behave badly in the same way. But machine-dependent behavior often appears certain zones, paths, edges, or repeated areas. That makes sense from a system perspective. Machines do not always apply force, heat, airflow, or contact uniformly. A roller may press more stronger in one region. Airflow may be stronger near one side. Heat may accumulate in one pass. Tension may be different across the ways. The result is spatial inconsistency. Some areas remain stable, other areas become unstable. The pattern is a clue that the machine environment is shaping the film response. This problem is not automatically proof of poor film quality. It is also not always caused by one wrong setting, and it is not usually a random issue that disappears after changing a single parameter. A single setting may improve the result, but the root cause often involves multiple interacting variables: transport, tension, heat, surface behavior, ink deposition, powder behavior, and the production duration. That is why the correct mindset is not which part is bad. The bad question is which interaction is unstable. When the thin film performs differently across machines, compare the system. Look at how the film fits. Look for left-right tension differences. Watch where the instability appears immediately or only after longer operation. Compare heat exposure, airflow, and curing behavior. Check whether ink deposition looks the same on the similar artwork and the production speed. Also notice where the defect appears. If it follows the feed direction, mechanical transport may be involved. If it appears more in one zone, tension, contact, heat, or airflow may be uneven. If it changes with print model or part structure, droplet deposition may be part of the cause. The defect location is not just a defect, it is evidence. The same film can perform differently across machines because DTF printing is not a single material process. It is a system. Each machine applies its own combination of mechanical force, tension, temperature, airflow, surface contact, and ink deposition dynamics. The film responds to those conditions. So the lesson is simple but important. Film performance is machine dependent. To diagnose inconsistent results, do not look at the film alone. Look at the interaction between the film and the machine. That is how DTF troubleshooting moves from guessing to manufacturing control.